Welcome to the Deep Dive. We're tackling a challenge today that I think many of you might relate to. It's that feeling, being completely overwhelmed by a new field, especially one that's just buzzing with acronyms and, well, a seemingly endless list of tools. Today, we're diving into data engineering. It's such a crucial field for making sense of, well, just the vast amounts of information we generate every single day, our mission. Cut through all that noise, we've got insights from a seasoned data engineer, and we're going to give you a clear roadmap. We'll unpack the essentials, the foundations, demystify the core job, what data engineers actually do, and even lay out a practical project blueprint, something end-to-end that can help you bridge that gap, from learning to actually doing.
Yeah, and what's really great here, I think, is the core message. It's actually pretty empowering. You absolutely do not need to know everything all at once. It's just not feasible. What you need is a strong foundation. Get that right, have a clear plan, and you're set. And that's what we want to give you today, a plan, basically, tailored to help you navigate this complex landscape. It's definitely complex, but also really rewarding.
Okay, so let's start right there. Acknowledging that feeling. You look at data engineering job descriptions for the first time.
Yeah.
And they're just crammed, right? Dozens of tools, different technologies. It really does feel like trying to drink from a fire hose. You're left wondering, okay, where on earth do I even begin?
Oh, yeah, it's a very common feeling. I definitely remember feeling that way myself. But the key, really, the solution to getting past that overwhelm is building that strong foundation. We can think of it like 3 essential pillars. If you make these solid, you can pretty much build anything on top.
All right, 3 pillars. Let's dive into the first one then, SQL. People always say SQL is king in data. But for data engineering specifically, what does mastery look like? How is it different from, say, how an analyst might use SQL?
That's a great question because it is different. It goes way beyond just select from table. For a data engineer, mastery means really getting comfortable with common table expressions, CTEs, for structuring complex logic, understanding complex joins, maybe across different kinds of data sets, and really knowing your window functions, things like row number, lead. They're crucial for many analytical tasks. And critically, understanding query optimization. How do you make your SQL not just work, but run efficiently? Your first instinct when faced with a business question should almost be, how can I model this in SQL? It's fundamental for structuring and manipulating data.
Okay, that distinction is really clear. Moving to pillar 2 then. A solid programming language. Python seems to be the big one here. What are the core programming things, the specific libraries that are absolutely non-negotiable for a data engineer starting out, and maybe what isn't as critical right away?
Right, Python's definitely the go-to. And you hit a key point. It's not about becoming a web developer. You don't need Flask or Django, not usually. For data engineering, it's about writing clean code, efficient code, modular code. That means really knowing your fundamental data structures. Dictionaries, lists, sets. And crucially, understanding when to use a dictionary versus a list, for example. Why choose one over the other? Beyond that, the libraries you absolutely need are pandas, that's your workhorse for data manipulation, and the request library. You need to be able to hit APIs, pull data from external sources, that's bread and butter. Things like, advanced web frameworks, GUI stuff. You can safely push those way down the list for later.
Got it. Clean code, core data structures, pandas, requests. And the third pillar takes us to the environment, where all this actually runs, Linux in the cloud. Why is this piece so vital? It's not just about writing code, is it?
Exactly. It's vital because your data pipelines, they don't run on your laptop, right? They run on servers, often remote servers. So getting comfortable with the Linux command line is, well, essential. You need to know your grep for searching through logs quickly. awk is super useful for text manipulation and script counter for basic scheduling of tasks. These are tools you'll likely use. And today, almost all those servers, they live in the cloud, so you really need to pick one of the big 3, AWS, GCP, or Azure, and start learning its core services. Focus on storage first, like AWS S3 or Google Cloud Storage, where you put the raw data, and then compute, like EC2 on AWS or GCE on Google Cloud. These are the virtual machines where your Python code, your pipeline tasks will actually run. So yeah, SQL, Python, and this Linux cloud environment is your foundation, your sort of operating system for data.
Okay, foundation laid. SQL, Python, Linux Cloud, powerful tools. But they're only useful when you apply them, right? Which brings us to the core job, building data pipelines. The basic idea is moving data from a source, like an app database or an API, to a destination for analytics. Now, anyone looking into this field immediately runs into ETL and ELT. These acronyms are everywhere. What's the difference and what's more common these days?
Yeah, that's a really important distinction, especially now. ETL, extract, transform, load is the classic way. You pull data from the source, you transform it, clean it up, maybe reshape it in your code or in some intermediate system, and then you load that clean data into your data warehouse. ELT flips that middle part. Extract, load, transform. This is the more modern approach, really enabled by how fast and powerful cloud data warehouses have become. With ELT, you often extract the raw data, just pull it as is, load it directly into the warehouse raw, and then you use the warehouse's compute power and maybe other tools to do the transformation inside the warehouse.
Oh, okay. So ELT kind of leverages the cloud warehouse's muscle more directly. Does that mean ETL is dead? Or are there still reasons you might transform before loading?
That's a good nuance. No, ETL isn't totally dead, though ELT is definitely more common now, especially for structured or semi-structured data. You might still use ETL if you have, say, very sensitive data that needs heavy anonymization or hashing before it even lands anywhere near your main warehouse. Or maybe highly unstructured data, like free text or images, that needs significant pre-processing before you can even load it meaningfully. But yeah, for the bulk of typical analytical use cases today, ELT is generally the pattern. It offers more flexibility downstream. And this naturally leads us into talking about the modern tool set that enables ELT and other data engineering tasks. You don't need to learn them all at once, but understanding the problem each tool solves is key.
Okay, let's unpack those tools then. Focusing on the why. First up, orchestration. Pipelines often have multiple steps, dependencies. How do you manage that? Schedule jobs, handle failures.
Right, this is crucial. That's where a tool like Apache Airflow comes in, probably the most popular one. Airflow lets you define your entire pipeline as a workflow. Technically, it's a directed acyclic graph, basically a map of all your tasks and how they depend on each other. Airflow then manages the schedule, run this daily at 2 a.m., handles retries if something fails, makes sure task B only runs after task A succeeds. It's like the conductor for your data orchestra.
The conductor, I like that.
Yeah.
Now, what happens when the data gets huge? Like really big, too big for pandas on one machine to handle?
Yeah, that's a common scenario. When you outgrow a single machine, you need distributed processing. And the big name there is Apache Spark. Spark is designed specifically to handle data volumes that are way too big for one computer. It distributes the calculation across a whole cluster of machines working together. Think of it like, instead of one person trying to lift something heavy, you get a whole team working in parallel.
Makes sense. Distributed power for distributed data. So you've extracted, maybe processed with Spark. Where does the final, clean, analytics-ready data live?
That's your data warehouse, or sometimes called a data lakehouse now, but let's stick with warehouse for simplicity. This is the central repository, clean data, ready for analysts, data scientists, business intelligence tools to query. The big players here, the leaders, are Snowflake, Google BigQuery, and Amazon Redshift. They're cloud native, built for massive scale analytics.
Got it. Snowflake, BigQuery, Redshift. And for that T in ELT, the transformation step happening inside the warehouse, there's one tool that seems to be everywhere now, dbt. What's the big deal with the dbt? Why is it such a game changer?
dbt, data build tool, really is a game changer. It lets you manage all your data transformations using just SQL, which many people already know. But, and this is the key part, it brings standard software engineering best practices to your SQL transformations. Things like version control with Git, so you can track changes, collaborate, roll back if needed. Automated testing, so you can write tests to ensure your data quality stays high. Is this column always unique? Is this value never null? And documentation. It makes it easy to document your data models right alongside the code. It basically makes your SQL-based transformations much more robust, reliable, testable, and maintainable. It turns SQL into a proper engineering discipline.
Wow, okay. SQL with software engineering discipline, that sounds powerful.
Yeah.
One last tool category, maybe a bit more advanced.
Right.
What if the data isn't in batches? What if it's constantly flowing, like website click streams or IoT sensor data, real-time stuff?
Yeah, for that real-time streaming data, you're looking at different tools. Apache Kafka is a major one here. Kafka is built for handling high-throughput, low-latency data feeds. Think of it like a central nervous system for real-time events. But here's a bit of advice. Streaming is generally more complex than batch processing. So my recommendation is usually get your foundation solid with batch pipelines first. Master SQL, Python, Airflow, dbt, a warehouse. Then tackle streaming later when you need it. Don't try to boil the ocean initially.
That's really practical advice. Focus on the core batch patterns first. Okay, so we've covered the foundational pillars, the core job of building pipelines, the modern tools. But then comes that classic challenge, right? The chicken and egg problem. How do you get experience if you don't have a job? How do you get a job without experience? Everyone faces this starting out.
Absolutely. And the single most important piece of advice I can give here is build something. You have to build something. A personal end-to-end project isn't just a nice to have anymore. It's essential, becomes your portable portfolio. It's concrete proof you can apply these skills. It solves that chicken and egg problem because you create your own experience.
Okay, build something. That makes sense. You outlined a blueprint earlier, API to cloud storage, Airflow, warehouse, dbt.
Yeah.
Can you walk us through that again, maybe highlighting potential sticking points?
Sure. And the biggest pitfall I see is people trying to make their first project too complex or getting stuck aiming for perfection. Start simple, but make it end-to-end. That's the key. So step one, find a data source. Pick a public API you find interesting. Reddit's API, Spotify, weather data, stock prices, whatever grabs you. Step two, extract and load. Write a simple Python script. Use the requests library to pull data from the API. Save it as raw files, maybe JSON or CSV, into a cloud storage bucket. AWS S3 is a common choice. That's your ENL and ELT, basically. Step three, orchestrate. This is where Airflow comes in. Set up a simple Airflow instance. You can even run it locally using Docker pretty easily these days. Create a DAG that just runs your Python script automatically, say, once a day. Boom, that's your first automated pipeline. Step four, transform. Now load that raw data from S3 into your chosen cloud data warehouse. Snowflake or BigQuery have generous free tiers, perfect for this. Then use dbt. Write some SQL models to clean that raw data, structure it, maybe create a nice summary table like daily Spotify tracks or hourly weather reading. This is the T in ELT. And step five, absolutely crucial for the job hunt. Document and share. Put the entire project on GitHub. Write a clear readme.md file. Explain what the project does, what the architecture looks like, even a simple diagram helps, and how someone else could potentially run it. List the technologies you used. Explain why you made certain choices.
That's fantastic. It really does cover all the bases, doesn't it? Python, cloud, S3, warehouse, orchestration, Airflow, transformation, dbt. It's like a mini version of a real-world data engineering workflow.
Exactly. It shows you understand the whole life cycle, not just one isolated part. It demonstrates practical application, and that leads directly into acing the job hunt. When you have this project, don't just list personal project on your resume. That tells them almost nothing. Describe it using bullet points. Focus on the skills and the impact, even if the impact is just enabled easier querying.
Right, so instead of just the project name, you'd write something like, designed and built a daily ELT pipeline using Python, Airflow, and AWS S3 to ingest and stage data from the Spotify API. Is that the idea?
Precisely. Or maybe another bullet. Modeled raw JSON data into structured analytical tables using dbt and Snowflake, improving data accessibility for potential analysis. Use action verbs. Highlight the technologies.
That sounds much stronger, like actual experience.
It essentially is. And then for interviews, be ready for a few things. You'll almost certainly get SQL problems, maybe on a whiteboard, maybe a shared screen. Practice those CTEs and window functions. Expect some practical Python coding too, often related to data manipulation, like here's a sample data set in a dictionary or list, filter it, aggregate it. And crucially, be prepared to talk about your project in detail. They'll ask why you made certain choices. Why ELT here? Why Airflow instead of just a cron job? They'll also ask about scaling. Okay, this works for 100 records a day. What would you do if it became 10 million records a day? Remember, the thought process you show in answering those questions is often way more important than having the single perfect technical answer immediately. How do you approach the problem?
Thinking out loud, considering trade-offs.
Exactly. Show you can reason about system design. Now, about continuous learning. There are great resources out there, but please, please avoid tutorial hell. That's where you just passively watch video after video, course after course, but never actually build anything yourself. So you won't retain it that way. For a really solid, comprehensive book, Fundamentals of Data Engineering by Joe Rees and Matt Housley is kind of the standard reference right now. Highly recommended.
Okay. Good recommendation. What about keeping up with how things are done in the real world at scale?
For that, follow the engineering blogs of tech companies. Netflix, Uber, Airbnb, Spotify, LinkedIn. Lots of companies share openly about the data challenges they face and the solutions they build. It's invaluable for seeing real-world applications and scale. If you do prefer video courses, find a well-regarded one that focuses on a specific tool you want to learn deeply, maybe Airflow internals or Advanced Spark. But the key is, build alongside the course. Apply what you're learning immediately, ideally in your own project. And one last pro tip, maybe the most important for long-term growth, Get comfortable reading the official documentation for the tools. Airflow docs, dbt docs, Spark docs, that's what senior engineers do. When they hit a complex problem or need to understand a feature deeply, they go straight to the source documentation. It's a skill you need to develop. If we zoom out and connect this all to the bigger picture, mastering data engineering, it's definitely a marathon, not a sprint. Stay curious, be patient with yourself, especially when things feel tough or confusing. And just start building. Don't wait for permission or the perfect moment. And remember, whatever background you're coming from, that's an advantage. Bring your unique perspective to the problems you solve.
That's a great way to frame it. So for you, the listener, what does this all boil down to? You should now have a much clearer, actionable plan. That overwhelming landscape. Hopefully it feels less like a tangled mess now. Still a journey, for sure. There's a lot to learn. But it's a defined journey, focused on learning by doing, grounded in actually building things. Which leads us to a final thought, a question for you to consider. What fascinating public API are you going to choose? What data source sparks your interest enough to kick off your very own end-to-end data pipeline project? What insights are just sitting there waiting for you to extract, load, and transform them?
Happy building.